during the demonstration, we also see that the live settings, and we will follow the controller where you can see it. So maybe Niklas, maybe you can switch over to show that the PKs. Yeah. So here we have the two PKs, and Niklas will go through a little bit what we expect to see during the welding, and obviously that there will be a root pass with a single wire, and as you can see here, in the first run, we will run 700 amps, 28 volt, and a speed of 45 centimeters per minute. That is for the first root pass, to make sure that we get a proper penetration, because I mean, we don't want to back gouge, we don't want to grind. So by doing this, we will make sure that we have a good slag release, that we get a proper penetration. During welding fluctuate a little bit, but I mean, here we can decide whether we want to set the amps and the volts and the speed. So I mean, it's a presetting. In some cases, you might have the wire feed speed as an input to your PQR. Then you can switch to that. But basically, I mean, what we are setting the amps and the volts, and then it will weld automatically.
Okay. So for ICE project, we have the two junction box, right?
Yeah, I mean, when we go over to the second bead, which we will see, that then we will also use the second torch where we have ice, and what Niklas is pointing at now is the trailing one. So in the beginning, what we are using 30% ice. It means that the wire feed speed of the cold wire is 30% of those of the hot wire. That will be done for the two next ones. But when we go to the third layer, then we will increase the amount of cold wire to get the real benefit, and that will also increase the deposition rate. Yeah. So please switch over to the, yeah, here we got. So we just have to make sure that we have the right temperature here. So what we use it to make sure that if there are any kind of humidity, what we are at 126 degrees centigrade. So it's still maintaining the preheating temperature. I mean, we want to make sure that our root pass is making a proper penetration, and that we've done when we've taken the macro to make sure that these parameters are good enough to make a proper penetration. So no need for grinding or for back gouging. And that will obviously save time in production, because back gouging is time consuming, it's kind of noisy and so on. Yeah. Niklas, could you switch from the PKs, just turn the camera around to show the weld head, but with a single plus ice?
It will come.
So I mean, basically what you see here is, could you get a little bit closer to the head? Yeah, if you zoom in there. And bring it a little bit more down.
Then I know what to aim.
Yeah. So I mean the leading wire here, which is connected to the flux feed, that's the single wire. The second torch is the ice setup, where you will have the two hot wires and one cold wire, with a separate wire feed. Now for the first run, we'll only do the single wire. Will you do any adjustments to the torches once you start the ice welding, or they maintain in the same position?
They will be angled. The DC will be angled up.
Yeah.
So it gets closer to the ice head.
Yeah. So for the first run, I mean, what we do it basically 90 degree to the base material, and then when we start to use both torches on the second run, then the DC will be angled. And let me just point out that the ice torch, which is in this case the one to the left, is always perpendicular to the surface. So the first will be angled closer to the ice torch, and that means that that will generate more penetration than with a perpendicular torch. And the second one will be used for the fill up. So any questions on the setup?
What?
Okay, let's bring that camera back to the PKs, and then I think what we're ready for the welding. So flux on, please.
Thomas. Amps, voltage, travel speed, wire speed, and heat input.
Now we're doing 24-25 kilojoules per centimeter, which is obviously 2.5 kilojoules per unit. You can switch to the weld head. And here you also see that the deposition rate for this first layer is about 10 kilograms per hour. As you can see, we can switch between the menus showing amp, volts, and speed into the wire feed speed. So as you can see, I mean, that there is an excellent slag release. No need to hammer anything, just brush it away.
Okay, I want to pick up the average of the wire feed speed. So I go into the menu tools and quality function, and I will find we have an average of 169 centimeter per minute for this weld.
So, I mean, in this controller, the PK, you're able to get a lot of quality data, production data to verify how you have actually welded. So everything is stored, and I mean, here we put in this document, I mean, what kind of current did we have, what kind of voltage, and then the system will calculate exactly how many kilos you deposited. You will also get the heat input level to make sure that it's correct. And you can also see that the heat input directly in the PK controller to make sure that you are, once you put in your parameters, that you're not exceeding the heat input limit. And now you can see that we put the torches a little bit closer, where you have the leading wire, 4 millimeter, still run on DC, and the second one AC ice with 2 hot wires, and you can actually see the protruding insulated ceramic nozzle in the middle where we have the cold wire. To the right, here we have around somewhere. So that Werner just correctly pointed out that maybe it's too noisy during the welding. So I'll think about that. Not talking. Thank you, Werner. So this is the first fill pass using both the single wire and the ice. And as you can see, I mean, what we are still having an extremely good slag release. No hammering, no grinding or anything. It's just kind of sweeping it away. And obviously, I mean, the most difficult part in subarc welding to get the slag release is obviously in the root, where you have the most narrow and tight position. And as you saw from the first run, it was easy. So, I mean, the further up you come in this bevel, the easier the slag release will be. and obviously therefore we can also go for some tougher parameters. So
Ulf. Bra.
Too much.
So we have a retraction speed. So I mean, when we bring the welding head back, it's moving at 2 meters per minute. So that could be set as a separate travel speed. And as you see, I mean, what we still have an extremely good slag release with this 1072 flux. And I mean, despite that we have fairly good high deposition parameters, and we know that we still got room to go. So without putting, let's say, too much effort in here, I mean, we have a very good slag release, we have high productive parameters, and we know that we can go one step up further.